Hi everyone, welcome to our video on using Riemann sums to help us approximate the area under the graph or curve of an f of x function. And they give us this setup where we have f of x equals the natural log squared of x from x equals 2 to x equals 4 with n equals 5. Okay, so what we're going to do on this one, so we're still going to graph. All right, so I'm got my Desmos ready, and I'm just going to plug that function in. So we have ln squared of x. Okay, so there's our graph right there. And so what we probably will want, let me just go ahead and scroll over so we can kind of see both. So they want it from n equals 5 with x equals 2 to x equals 4. Okay, so I'm just going to really zoom in there. There's from 2 to 4. Okay, so like that. All right, so that's where we can kind of see it. Okay, and then what we really want eventually is a table. So I'm going to get this table kind of going. Okay, but first, let's go back to what we have here in our problem. Let's start to set it up. So I wanted to just get the graph. And using our left endpoints, using our right endpoints, we'll take an average, and we'll also use the midpoints. Well, these two have a nice connection for it. What we want to do, so on this problem, I'm going to just reference the graph of our function, and I'm not going to probably draw it every time. So let's first just get our base for each of the rectangles, which is our delta x. And in this problem, it looks like our a is 2 and our b is 4. And our formula is just to subtract the bigger x with the smaller x, and then divide by our number of rectangles that they're going to say, so which is n. So we're going to have 4 minus 2 over 5, which gives us 2/5, or as a decimal, 0.4. Okay, so that's the base of each rectangle. Now, what we really want, I'm going to let's reference what we had in our last problem. So notice with our left endpoint, I started at 2. And then I go every length of the base there to get our new endpoints. Well, the way that I'm going to call this is our grid points. So they might use some other vocabulary. So I'm going to call these grid points, which means start at whatever your x value is that starts. So it's going to start at 2. And then go every length of the base until you get to this final one. Okay, so if I go another 0.4, I'm at 2.4, and then I'd be at 2.8, and then I'd be at 3.2, then I'd be at 3.6, and then I'd be at 4. Okay, so these are the grid points. And the way that we're going to break this down, I'm going to do it just like I did the last one. So I just want to avoid doing this sketch each time. I mean, the sketches are nice, but all I'm thinking is, well, now that I have the grid points, just start with your most left one for the left Riemann sum. So I'll keep this one in red. These are the x values that will help me find the heights for my left Riemann sum. So I'm just going to label it left, 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 and left until I have 5. So I have 5. These are the x values that will help me with it. So using these grid points, now I'm going to make a table that will be shared between the two of them. Okay, so 2, 2.4, 2.8, 3.2, 3.6, and 4. And then now let's find our y value. So that's now back to our graphing calculator. And then now I just want to plug in those grid points for our x. Okay, so we have 2. We had 2.4, 2.8, 3.2, 3.6, and 4. And you can't see them. There they are. And then all the others I don't need. So I'm just going to delete them. There. Okay, so there's 1, 2, 3, 4, 5. So notice we have 6 grid points. We should only have 5 rectangles, though. So that's okay. Again, I already marked it. The left, 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 and left. Those are our 5 that we would want for our x coordinates. So now I just pair them. So it'd be this, 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 and this for, again, our left. So let me mark that. Let's just kind of keep this here to the side. So this is our left rectangle's first height. Then this is our second, the highlighted, third, fourth, and fifth. Okay, so there we go. So let's go ahead and copy them. Okay, so I'm going to copy those. Let's do it to 3 decimals. So 0.480. 0.766 is the next one. 1.060 is 1.060. There we go, is the third. And then we have 1.353 for the fourth. And then 1.641. And then for the fourth one, for x equals 4, we have 1.922. Okay, and so like I said, so I had these are our left ones, the ones that I have right here. So all I'm going to do is just mark it as here's H1, here's H2, here's H3, here's H4, and here's H5. Okay, so that is how I want to break it down. Instead of doing our graph every time and drawing the rectangles, I'm going to just jump straight to, so this is, I'm just using it as a reference, and then getting our important grid of values that helps us along the way. Okay, so using the left endpoints, again, our area is the base times the height of those 5 rectangles, and I'm going to do it like that to abbreviate, so H1 plus ... all the way to H5. And then let's plug them in. So we have the area is the base, which we found is 0.4 times the 5 heights. Now I'll color code them in red. So the 0.480 plus 0.762 or 6. Oh, so my pen's not the best. That's 66. There. Okay, so 0.766 plus 1.060. Plus 1.353, and then that one more, 1.641. Okay, and so now we can add these up, and well, again, I'm just going to use my calculator to help us in this problem so we can do it without mental math. Okay, so I have 0.480 plus 0.766 plus 1.060 plus 1.353 plus 1.641. Okay, so it's 5.3 when it all got added up. So 5.3, and then we'll just need to multiply that by 0.4. Oop, let me change it back to black ink. So 0.4 times 5.3. And then, well, when we multiply that, I'm going to do my calculator one more time. Let's times it by 0.4, and we get 2.12. There it is. Okay, so we found that area. So again, it represents some total when it involves applications. For now, though, it's just finding this area, just like a regular geometry problem. All right, so it's using a lot of rectangles. Now our right endpoints. Well, again, it's the area equals the base times our 5 heights. This time around, so I'll mark them in blue, well, using our grid points, like in our last one, let me reference that, it was starting at the rightmost one, and then going until we had the number of rectangles that were needed. Okay, so that would mean start at your rightmost grid point, so that's R, and then get 5 of them. There we go, so it's these 5. Okay, so that means these here are heights 1, height 2, height 3, height 4, and height 5. Okay, and so to save a little time on it, I am going to write it, let's just keep it all in blue. So I'm going to do the area equals the same base, 0.4, times our height 1, which now begins at 0.766, plus then 1.060, plus 1.353, plus 1.641, plus 1.922. So there's the 5. And then, well, again, it's just right back to the calculator. Using actually the Desmos calculator might be better, but then I lose this. I could do another one. Okay, anyway, so using the one that's on there, let me go ahead and type, there it is. Here's our scientific calculator. This one might be a little easier because I could have copied and pasted, and that would have saved a little time. So my fault. I should have done this first. Okay, but anyway, so let's go ahead and get our numbers there. Okay, I'm gonna just scroll up until we see it all. There we go. Okay, so now let me plug those in. So I have 0.766 plus 1.060 plus 1.353 plus 1.641 plus 1.922. There it is. And it's that 6.742. And then I'm just going to take that answer and times it by, so 6.742 times it by the 0.4 again. And we'll get our last one, 2.69. We'll do it to 3 decimals, 2.697. Okay, so we have 2.697. Okay, so that's the area using the right Riemann sum. So notice they're kind of close, like in our last one. So I didn't draw a picture again to save a little time. But one probably overestimates, one probably underestimates, depending on the scenario. So taking the average of the two can make it pretty close. Okay, so the average is pretty easy, though. This is our favorite part of the problem. 2.12 plus 2.697 is going to get divided by 2. Okay, so now one more time back to this. 2.697 plus 2.12. And then we'll hit enter. And then we'll just divide that by 2. Oh, I messed it up. 4.817 divided by 2. Okay, so sorry. Yeah, I got to kind of, this calculator's a little big. I could have shrunk it. There, that would have been better, huh? Sorry. Okay, so 2.40. We'll do it again to 3 decimals. 2.409. Right there. Okay, so we've got those. So the left one, the right one are done. Now one more. Find the midpoint. And then we took the average again. This is probably more accurate than either of these, the average of them. All right, so the midpoint is still using the area formula. It's just, again, our bases are different. So we have, or the heights are different, I mean, sorry. So the base is going to be the same. Okay, so I'll have 5 heights for the rectangles. All right, this time around, I want to find the midpoint of each of them. Okay, so let's go back to our calculator. Okay, well, the midpoint between 2 and 2.4, one way to do it is to add the two together and then divide by 2. So that is one way. So you could, let me take this. So in case the numbers are harder, let's go ahead and take our grid points that we had. The 2, the 2.4, the 2.8, the 3.2, the 3.6, and the 4. And to find the midpoint is just to add these two together. So we add these two together and then divide by 2. So 4.4 divided by 2 would be 2.2. Okay, so these are the mid x values. So we hit 2.2 and then comma. Okay, so keep doing it with the next two. So it's just stacked. 2.4 plus 2.8 is 5.2. Divided by 2 would be 2.6. Okay, or at this point, okay, so one other way to think of it is you could just add 0.4 now, because that's still the base of the rectangles. So 2.2 plus 0.4 was the 2.6. So that's what I'm going to do. So let's continue adding 0.4. So we'd get 3, 3.4, and one last one, 3.8. Okay, so these are the x values that I want to use. And so eventually I would want to use my table. Okay, so I'm going to use those in my table. Let's get rid of these here. Okay, so we said 2.2, 2.6, oops, 3, 3.4, and 3.8. So those were the x values that I wanted, and then these are the 5 heights. Okay, so those are the 5 heights that are going to be used. I'm going to go ahead and just move it over, and we'll copy it straight into this formula. Okay, so I'm going to move it so I could see it, and then now let's plug it all in. So our base is still 0.4, And our heights are in the table that is on a different screen, but I can plug them in so we have them all anyway. So it's 0.622 to 3 decimals plus 0.913 to 3 decimals plus 1.207 to 3 decimals plus 1.498, and then one more plus 1.782. Okay, so and then now we just need to add those up one more time with the scientific calculator. Okay, so almost there. Okay, so I have 0.622 plus, let's go ahead and move it so you can see it. There we go. Okay, 0.913 plus 1.207 plus 1.498 plus 1.782. So there's that, 6.022, and then we're going to take that answer and times it by 0.4, and we get the 2.409 to 3 decimals. Okay, so we finally got, so our area is 2.409 to 3 decimals. Notice on this problem, that is a match to the midpoint, to the average one. That's a coincidence. I mean, it did not happen the first time. 73 was not 74. Okay, so that does not mean if you get number 3, 4 will automatically match. Here I am losing accuracy with my decimals, so that could be one reason. But I guess on sometimes it does match. Okay, so that's cool. Okay, but that's it. Okay, so if you have questions, so these are long problems, and it's a lot of calculator work, so just keep going back and forth. Notice on this one, I only wanted to get the graph, and after the graph, I was fine with just getting the midpoints for the final portion, but I didn't care about drawing those rectangles in. I mean, you can if you want to, but I'm gonna try to save some time on this video, and I just wanted to reference a previous one. Okay, anyway, so that's it. If you do have questions, please let me know. Otherwise, thanks for watching, and I will see you again.